Dear students, in this lecture we will be doing ester hydrolysis by using a base. So, in the last lecture we took up ester hydrolysis using an acid. Now, ester hydrolysis using a base proceeds by this simple mechanism, and the one which we will be doing is, of course, the one which is most common. It is called as BAC2, that is base catalyzed acyl oxygen fission of the molecularity 2. Now this reaction is a common reaction, and in fact it is the one which is generally preferred as compared to the acid hydrolysis of esters, because this is not reversible, unlike the acid hydrolysis, and moreover the products which are formed can be easily separated, and at the same time it is also faster. So it has a number of advantages, the base catalyzed hydrolysis, over that of the acid catalyzed hydrolysis. It is also called as saponification for the simple reason that triglycerides, they are acted upon by NaOH to give us soaps. Soap, hence the name saponification. We will see that reaction soon. So this is our ester. When attacked by the OH negative, this will lead to this tetrahedral intermediate. This tetrahedral intermediate, which has got OR dash, this OR dash will be pulling electrons towards it once this has been formed. So this will facilitate and this will act as the leaving groups. So R dash O negative, after pulling these electrons, will leave. As a consequence, what will be formed? An acid will be formed. The acid which is formed is RCOOH, and now because R dash O negative has been formed, this R dash O negative has a great tendency to withdraw these hydrogens from here. Why? Can anyone think as to why? This is for the simple reason that because we know carboxylate ion is more stable as compared to the carboxylic acid. So with the help of R dash O negative, that is the alkoxide ion which is formed, this as a base will hence abstract these H positive, which will lose the electron pair here, this bonded pair, and we will get a resonance stabilized carboxylate ion. And as we can see, the arrow is depicting, this is an irreversible reaction. Therefore, once this has been formed, R-OH, now the alcohol R-OH has been formed, at the same time this very stable carboxylate ion, this reaction, unlike the acid catalyzed hydrolysis, is not reversible. Therefore, we will be getting a very stable two products. One is the carboxylate ion and the other is our alcohol, R-OH. This carboxylate ion, because NaOH, the base is used, so this will form the sodium salt of the carboxylate ion. And this sodium salt can be converted into the acid by a simple reaction with an acid, mineral acid. In the presence of H positive, this will be converted into RCOOH. Once again, in this mechanism, like the earlier one, there is the fission of the acyl oxygen bond, which can be very well predicted. How? Because we know if we take the labeled oxygen of RO dash negative, the RO dash is the portion which is formed from the alcohol, Therefore, we will see that on hydrolysis, we will get R-O18H. That is, in other words, this labeled oxygen will be incorporated in the alcohol, thereby showing that there has been a fission of this acyl oxygen bond. This is the bond which has been broken. This is clearly shown that this bond is broken. Moreover, if we take the ester such that the carbon is optically active. Which carbon? Again, the carbon which is attached to oxygen. That is the portion which has been derived from the alcohol. So, this, as we can see, is optically active. Therefore, what will happen after hydrolysis? The product that will be formed will retain the stereochemistry as was discussed earlier in the case of our acid hydrolysis. So it will be having the same stereochemistry as was present in the case of this ester, thereby showing that has this carbon, in other words, this carbon has not been affected. The carbon. So what had this bond been broken, we would have got an sp2 hybridized carbon. Therefore, there would have been a change in stereochemistry. But this bond remains intact. Therefore, the stereochemistry also remains the same because the bond between this oxygen and this acyl carbon has broken. So this is therefore BaC2. Now coming to an interesting aspect as to why this base catalyzed reaction is also important in the living organisms. The triglycerides in our body, in the presence of the enzyme, because they lipases, the enzymes which are within the system are called as lipases, because these are lipids, isn't it? So what happens that these are therefore broken, these triglycerides, and we can say they are hydrolyzed. Triglycerides derived from glycerol. So this is in a way like ester hydrolysis only, because CH2OCOR, CHOCOR, what is this? This is a triglyceride. Now this triglyceride is by means of enzymes in the body changed to the acid. Glycerol as well as this acid is formed. And these acids, triglycerides, are esters of long chain carbons. Hence, a lot of energy will also be released. And therefore, this reaction is very important in fat metabolism to facilitate breaking of these bonds, these fats, and to release energy. At the same time, besides being important in the living organism, it is also important in from the industrial point of view, because this reaction, like the stearic acid, if R is long chain fatty acid such as stearic acid, so 3RCONA positive, this has been formed. What is this? Sodium salt of stearic acid, sodium stearate. This is nothing but soap. So that's why it's important in the industry for the manufacture of soaps. Because now this soap, as we can see, will have two ends. One is this ionic end, O negative, Na positive, charge, the polar end. And the other is containing a long chain carbon, 3R, indicating there are a number of carbon atoms. Therefore, this will have both a hydrophilic as well as a hydrophobic end. And this helps to dissolve the dirt and wash it away with the polar water, O negative, Na positive, and helps it to dissolve in water. And the R helps, because that's hydrophobic, that helps to dissolve the fats and the oils which are present in the dirt. That is why also this reaction is important. So in other words, the base catalyzed reaction is more often it occurs, it is more important, since it is not reversible and the products can be easily separated, and moreover it is much faster than the acid catalyzed mechanism.